Hi, welcome back to Imperium Learning. I went a little bit over time in the previous video, um, but I was just explaining why you should probably, after you've estimated an Arch 1 model, and if your residual tests show that your model suffers from both autocorrelation uh, as well as exhibiting arch effects, then you should probably just move on to the Garch 1-1 model. The reason why is because if you, say, have to estimate an arch model of order 5 in order to uh, remove the arch effects and the autocorrelation from your residuals, that will mean that you have a lot of terms in your conditional variance equation. Whereas if you're estimating a Garch 1-1 model, which will probably have at least the same explanatory power as as the as the Arch model, it will be able to explain but it will probably have more explanatory power actually. It will have fewer parameters in its conditional variance equation, and that will mean that your model is more parsimonious, and it's always good to have the most parsimonious model. The most parsimonious model is the model with the fewest parameters, but at the same time still has the same level of explanatory power. So just remember that. Also, I just realised I have another um, PowerPoint slides. It just gives you an example of the kind of things that you can write to discuss your results in any essays that you're writing. Again, I should just say that this is really directed towards any undergraduate or postgraduate students. I just realised that I've made a slight error. That is not supposed to be alpha 1. Alpha 1 equals 0.420157. The resid minus 1 to the power of 2 is actually your u squared value in the previous time period. So in other words, alpha 1 equals 0.420157, and then your, hang on, yeah, and so the resid minus 1 to the power of 2 is actually this term here. So if I just very quickly change that, and then that's what it actually is. So just very quickly, things to discuss. Just comment that the coefficient is 0.42, so it's positive and it conforms to the non-negativity constraint, and also it's significant at the 5% level. So what that means is that the immediately previous value of the error squared term is a significant explanatory variable for the conditional variance of the error term. And yeah, so after that, just make sure, after you've estimated your arch model, make sure that you've done your residual tests, and your model will probably suffer from autocorrelation as well as exhibiting arch effects, but that's okay. Use that as your justification for moving on to the Garch 1-1 model, and you're going straight to a Garch 1-1 model rather than an Arch 5 or an Arch 6 model, because your conditional variance equation will be more parsimonious. It will be more parsimonious because it contains fewer parameters. Okay, well that's it for now. I'm now going to be moving on to the Garch 1-1 model. So that's everything that I wanted to say. So bye now.